Just a minute.
Hmm.
Okay, let's. So today we will be doing functions, and we will
Hmm.
actually discuss the domain and range of a function. This is a very long topic, so it takes actually
Okay.
whole class. In case we would be able to finish domain and range of function by right time, then we will also do the inverse and the composite function also. Right? Okay.
Hmm. Okay.
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 Let's start. So I mean the this A level mathematics belong is like 11th of a mathematics in India.
A level is like, yeah, 11th and 12th.
So I can say that you are a 11th student if if you would have been in India.
Hmm. So next year I'll be in 11th.
Okay, presently you are in 10th, right? So
Yes.
you need classes for the 11th class.
Yeah, it's the
You're, pre- you're,
holidays now, so I want
you're
to prepare for
preparing.
next
Okay,
year.
okay, you're preparing right from now.
Hmm.
Okay, okay, let's start. Okay, so uh, do you know what is function? Any idea about this thing?
Hmm. Yeah, it's something like y is equal to 5x. Um,
Y
the
equal to
equation relating
okay
5x.
5x. Okay, okay.
Like
So
example.
so can I say that y is output and x is input,
Yes, sure.
right? So basically,
Hmm.
function is nothing but a relationship between a input and output, right?
Hmm.
And
Yes.
every input has distinguished output, distinct
Hmm.
output. So but an output can may have different input also. For example,
Hmm.
uh, let us suppose we okay all the inputs when we do the mapping in function, all the inputs are kept
Hmm.
on left hand side, and all the outputs are kept on the right hand side. Okay, so what we do,
Hmm. Okay.
suppose this this ellipse belongs to input and this ellipse belongs to output. Okay,
Okay.
let us suppose
Hmm.
the elements in of the input are -1, 1, 7, and 5, and the
Hmm.
output
Okay.
will be the square of them.
Okay.
So my square of -1 is 1,
1.
and square of 1 is also 1,
Yes.
and square of 7 is 49,
Okay.
and let us suppose, sorry,
5 is 25.
this is not 5, this is zero point 0.5. Okay, so
Oh,
let us
point 5.
this will be 0.25,
Yes.
right? So how they
Yes.
are related? This -1 is related to 1, 1 is related to
S-
also 1,
yes.
7 is related to 49, and zero point 0.5 is
Hmm.
related to 0.25. And
0.25.
and
Okay.
if I make the arrow from input to output, it would be like this. Okay,
Okay.
so this is actually mapping of a function. But
Hmm.
we
Okay.
can do mapping of a function only and only at that time when uh, every input has distinct output. So you can see that
Hmm.
-1 has a distinct output 1, and 1 has also a distinct output 1. But this output may have two different inputs.
Hmm.
Okay, so only
Okay.
then then the function is defined. This is actually a definition of a
Okay.
function, right? Okay.
Hmm. Yes.
So we can also write this thing in like this, in a form of set -1 1, 1 comma 1, 7 comma 49, and zero point 0.5,
Okay.
0.25. So the x-axis, that is -1 1 7 0.5, they they are the inputs, and the y-axis, this 1 1 49 0.25
Yeah.
are the y-axis, right?
So the coordinates.
Yeah, these are basically the coordinates, right? So uh, the inputs are also known as domain of a function,
Okay.
and all the outputs are basically range of a function.
Oh, okay.
Okay. So suppose we draw it in a form of a graph. So let us suppose this is a graph. This is x-axis. This is y-axis. All inputs will come in x-axis, and all outputs will come on y-axis, right? So uh, the one will be uh, this a minute. One will come here,
Yes.
and -1 will come here. Let us suppose this is a -1 and this is 1, right? And suppose
Yes.
7 this is a 7, and this is a 49. This is 50, suppose, and 49 will come just below this. So this will be 7 comma 49, right? And this
Yes.
this 0.5 0.25 would come somewhere here,
Yes. Correct.
right? Okay.
Right.
Now you just see one thing, that uh, for function there is no vertical line. See, vertical line means
Oh.
that no two values can have same x value.
Okay.
Okay, so this is so whether uh, the values which are given is a function or not, we can find out through a vertical line test also, which is known as vertical line test.
Okay.
If the vertical line is not being made, then it is actually a function. So suppose I give you just a minute. Suppose I give you a set 0, 7, 0, 8, 1, 7, 1, 8 coordinates I am giving you, 1, 9, and 7, 10. Can you tell this is a function or not?
It's not a function
Why it is not a function?
because for the first two coordinates, they both have the same x value.
Right. So even not only for the first two values, even third, fourth, fifth are also having same x values. So this is not a function.
Yes.
So now you have understood how can we define a
Yes.
function, right? Okay. Now
Yes.
let's go ahead. Now we actually have to find for different functions the domain and the range, right?
Okay.
So let us suppose you have been given a function fx equal to x square.
Okay.
So to actually find out that what is the domain of a function, we actually have to find where it is not defined. Where
Domain
that
is the input, right?
domain is the input.
Okay.
So x square is the output,
Mm.
and x is the input. So can we say that this output is defined for all values of x, that is all real numbers?
Yes, we can.
So we can say that the domain is actually R, real numbers, all real numbers. And
Yes.
what about the range?
Range is the output, right?
Yeah,
It's always positive.
it's all for positive. So we can say that all values, suppose if I say fx, then it should be greater than or equal to 0.
Yes.
So we can say that range is range, all values greater than or equal to 0, and for domain, all the real values are belongs to the domain.
Yes.
So this is how we actually find a domain and range. So we will discuss
Okay.
in today's class for different functions, how do we find domain and range, because they are
Okay.
the methods for finding different functions, domain and range, are different, right?
Okay.
Let us
Yes.
suppose you have to find the domain of fx equal to 1 by x. Can you find the domain of this?
Domain is the input, right?
Yeah.
So The domain is x to the power of -1.
No, domain is all values. This is basically input. 1 by x is the output,
Okay.
right?
So it's always positive.
Even even negative values are also possible. Output is
And
defined even for negative values also. Suppose x is equal to -1, then fx will be equal to -1.
oh,
If x equal to -2, fx will be equal to -1 by 2,
okay.
right? So, but
Yes.
for x equal to 0, fx becomes infinity.
Okay.
So all the real values minus 0,
Okay. So they have to be greater than 0.
greater than 0 or less than 0, but it cannot be 0,
Okay.
right? So that this will be a
Yes.
domain of a 1 by x, right? And
Mm.
what will be the range of 1 by x?
Um, it will all the way be from above, should be above 0.
It can be above 0 and it can also be less than 0 again.
Less than
uh,
0.
so uh, so 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 all the values greater than 0 and less than 0 uh, is okay for this for domain also.
Okay.
Sorry, range, for range also, right? So let's
Yes.
do another question. Can you find a domain for fx equal to root x?
Okay. So basically, it cannot be negative
Why it cannot be negative?
because it will become an imaginary number.
Right. So all the values of x greater than 0 or equal to 0
Mm.
also, right?
Yes.
Belongs as a domain of this function.
Yes.
And let us suppose you have to find a domain of this function.
Mm.
You have copy pen with you also.
Sorry.
You have kept copy and pen with you also, notebook and pen.
Ah, yes, of notebook and pen.
Okay, please keep it with you. So because many times you have to
Okay.
solve the question.
So it's 1 over x minus 1 minus 2.
1 over,
Square root x minus 1 minus 2. Is it what you wrote?
yes, x
Okay.
minus the square root is on x minus 1, not on 2.
Okay. 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 So x has to be greater than 0
Okay, this is the only
because
criteria.
or else uh,
Try to think actually. See, we know. I will give you a hint. Then you try to find out. We know
okay.
that denominator cannot be 0.
Hmm.
Otherwise,
Right.
otherwise fx will become infinity, and it will not be
Hmm.
defined, right? So
Yes.
you have to
Yes.
find out that value for which x is not that it will become that the denominator will become 0. The value
Okay.
of x.
Sure.
So and also x the square root can also be cannot be negative, otherwise it
Yes.
will be
Right.
imaginary. So you have to find those two values of x where it like where the denominator would become 0 and also the square root would become a uh, would become negative,
Right.
right?
Okay.
Okay, now do the question.
Okay. So x cannot be 5.
X cannot be 5, that's good.
Yes.
And
And x has to be greater than 0.
x or x minus 1 has to be greater than 0
Hmm.
because square root is in x minus 1.
Hmm.
So x
X
minus 1
cannot be
is
0.
no, x cannot be, x can be, can, okay, that's okay, but x minus 1 should be greater than 0
Hmm.
so that x minus 1 always remain positive.
Yes.
0 or greater or equal to 0.
Hmm.
So x should be greater than or equal to 1.
Really correct.
So basically the domain will be all the real numbers uh, which are greater than or equal to 1, but x should not be equal to 5.
Hmm.
So
Correct.
this will be the domain of this function.
Oh,
Got it?
okay. Yes,
Okay,
got it. Thanks.
right. Uh, Now we can determine range and domain also through graphs also. Okay, we can find them
Okay.
through
Yes.
graphs also. So let us suppose I am making a graph. This is the x-axis, this is y-axis, and suppose you are
Hmm.
making a graph of fx equal to x square. This will be a parabola.
Yes.
Okay, my drawing is not good, so don't please pardon me for that.
Okay.
And uh, fx equal to 1 by 12 x cube. So this will be somehow like this. Fx equal to, this
Okay.
is fx equal to 1 by 12 x cube, and this is fx equal to uh, x square, so x square, right?
Hmm.
Okay.
Correct.
So how will we find a domain and range now? So all the values in x-axis will be domain, and all the values in
Hmm.
y-axis will be the range, right?
Yes.
So
Yes.
when we are talking about fx equal to x square,
Hmm.
so the domain will be the values are going in from uh, minus, so from 0 to minus infinity, as well as 0 to infinity it is also going.
This for all real numbers.
So it's for all real numbers. But when we are
Yes.
talking about the range,